Okay, guys, welcome back. Can everyone hear me? So just a thumbs up if you can hear me. Perfect. Okay. So the next section of our lesson will be discussing about what I mentioned before, a data analytics mindset, and we'll be defining certain things because especially the programming languages which we'll be using. As I said, next week we'll kickstart with the SQL, then the following week we'll start with Python. So I'll just be giving you a brief overview of what SQL is and what Python is, what the differences are. And we'll go a little bit into the job market, what is happening in the job market in data analysis and data science. Obviously, obviously some people some people are not here for jobs. Some people are here to apply the data science to their businesses or to their current jobs or for career progression. Some people are here to actually find jobs in data analytics. So I'll be able to just give you a brief overview of how the market looks like in terms of what the requirements are, so that you just start having the thought process while you're learning and making sure that you're ticking some of the boxes of what is required in the job market. So yes, data analytics mindset. So the first thing about a data science or a data analyst is about the curiosity. So you have to be really, you have to be curious. You have to be able to search a lot of things. That's why at the beginning of this course, I provided a link for us to be able to install software, and amazingly, most of my learners were able to do that on their own, successfully install everything, and it was for a purpose. Obviously, I could still have a session with each of my learners. I don't have more than 20 learners, so I could have a session with each of my learners to help them install the software. But I decided no, it will be good for them to be curious, to search things and have issues and try to solve the issues, because that's what the data analyst does. We have issues every day due to we have, oh sorry, is there someone that doesn't have access? Okay, I think it's fine. Okay, okay, sorry. Yeah, sorry for that. So I thought there was someone who didn't have access, but anyway, yeah, so it helped everyone to be very curious, try to solve problems and so on. Again, I provided a pre-program activity on data analytics to give people a foundation of what data analytics is. And I've had very good feedback from a lot of the learners that LinkedIn video was very encouraging and very helpful in them, giving them the foundation of what data science or data analysis is all about. So there's this part of learning. So there's this continuous learning. I told people to just do two exercises, two sections of that LinkedIn, but I was amazed that people actually got certificates, and that was amazing. That just shows us more of the continuous learning process. You have to be a critical thinker. You must ask questions. So nothing is the right thing in data science, because we tell the decision makers about the data. We're telling a story. So we have to be in that position, because the decision makers will always ask us a lot of questions. So you have to be able to think critically. You have to ask things like the why questions. You have to ask what you are trying to solve. What is the question you're trying to answer? What is the problem you're trying to resolve? And how are you going to resolve the problem? So you have to be able to build a whole algorithm, which is a step-by-step process of how you believe you can execute a certain problem. And I'll show that in my data portfolio session, which is the last section of this lecture. I'll show you how we went through a step-by-step process to solve a problem. And you obviously have to be a problem solver. Accuracy and integrity is of utmost importance. I know there are a lot of researchers among my learners, and obviously researchers already understand integrity, because what you say is what you believe. There are a lot of people that don't understand data science, the decision makers that don't understand. So when you tell them your sales in December dropped because of the weather, they will believe you. And if it's a lie, they will go with the lie. So we have to have that integrity. Remember, you are analyzing data. The data must not answer your question. If you want to get an answer and the data cannot answer, tell the decision maker, the data shows this, and this is what the data tells you. The data, unfortunately, cannot please you. You wanted to understand whatever, we wanted to see that your sales are booming in December or in January, but your sales are actually dropping in December. It's what the data is telling you. So you have to have that integrity. Accuracy is of utmost important. You have to be accurate in your decision. So you have to verify your code, verify your data. When you clean the data, you have to double check that the data is actually clean. If you replace missing values in a data with, let's say, 0, you check that those missing values are actually replaced with 0. So you have to do a lot of sanity check, which obviously I'll teach you how to do a lot of sanity check of your data, checking that things are doing what you do. You have to be able to communicate. Teamwork and communication are very important because most of the data you will get, you don't know anything about the data. I showed you at the beginning about my area of expertise. I've worked in healthcare, transport, behavioral science, government institutions. I've worked in so many different institutions. So you can imagine when I go to the Nottingham City Council and they give me data about social work, social care, or social work, I don't know anything about social work. So I need to collaborate with the social care workers. If I go to the police and they give me data about crime, I don't know anything about crime. I need to collaborate. I need to ask questions. What does this column mean? What does this data mean? Why is there 6? Why are the children of this age? Why are there 6 rows and 5 columns? I have to ask those questions. So it's a very multidisciplinary training. So a lot of people ask me, what is your domain? I'm no domain. I'm a data scientist. As a data scientist, I can work in any company. I can work in finance. I can work in any company. But I need to collaborate with the people that understand the data. You're not a king. So you need to always understand people are domain experts. They understand the data, that the people who have collected the data. So they understand firsthand the data. So you need this team collaboration. You have to be innovative and you have to experiment. Experiment is still on the hands-on. You have to try things. You have to see if you replace missing values by 0, how does the performance increase? If you replace missing values by -1, how does the performance increase? You have to try things because in data science, there are procedures, but sometimes there is some sort of try and error. So what I'll call experiment, right? You have to run things in different scenarios to be able to answer a question, and you present those scenarios to your decision makers. I removed all the females in the database and I ran only with the males. But when I added the females, this is the performance I got. Therefore, the females have an impact on the model than the males. You have to try those things, right? Either of just not just running the data with just males, but you have removed the males, run the data, remove so you have to try things to give more information because you want to process the data as much as possible to get as much information and to answer as many hypotheses as you can. So that's the mindset. So that's what we'll be trying to build throughout this course. So to start with, as I said, next week we'll be starting with SQL. So before that, it will be good to understand the entire pipeline of the data. I think I presented this in my YouTube video, but unfortunately I didn't add this in this lecture. But anyway, the pipeline starts with creating the first thing about data. So imagine data, right? Imagine me talking to you. Where does the audio go into? It goes into a database, right? Imagine you tweeting. Where does the tweet go into? It goes into a database. So the first thing in the data world is to create a database. Obviously, most of the times the data analyst is not in charge of creating that database. So there is what we call a data engineer. The data engineer will create the database. So data engineers will say, okay, there is this database of students in the University of Nottingham. He will create that database. He will create a table which will store information for students. He will create another table in the database that will store information for teachers. He will create another table in the database that will store information for courses. So let's get a simple, let's just imagine a simple university database that has students, teachers, and courses. So just as simple as that. Then when a student registers, so when you go and you pay your tuition fee, they will always ask for you, they will always ask certain information. What's your name? What's your number? What's your email address? All this information in that system. When that admin clicks send, or when if it's a website, when you click submit, when you register and you submit that information goes into that database that was created by the data engineer. And if you are a student, that information will go to the table called students. If you are a teacher and you are employed by the university, your information, when you are employed, they'll ask your name, your number. That information will go to a table in the database called teachers. That data will be there when the university creates courses. They will add the information about the courses into the courses table. So now there's a database of students who have registered. There's a database of lecturers who have been employed, and there's a database of courses. There will now be a linkage. So the university will say, okay, Dr. Henry will be teaching maths. So Dr. Henry now will be assigned the subject called maths, and that information will be updated in the database. So you can understand that when the university is being run, everything is being run, information keeps on being populated to the database. So in 1 year's time, the university will have a large amount of information. We'll have information about the students' assessments, the grades in each of the courses, the teachers' assessments, the courses the teachers teach, and you have all that information in the database. Then the university will come and say, we have this information, but we don't know much about, because the database has information, but the university does not know how many teachers teach what course. It does not know which courses are having the lowest grade. It does not know which courses are best performing. It does not know which students have not paid their school fees. It does not know anything, because every information is in a database, and the database is huge with many tables. The university says, okay, I want to hire a data analyst. A data engineer has done that, has created a database. Now I need a data analyst to retrieve certain information from the database and analyze this data and provide me insights about what's happening in my university. That is when a data analyst comes into the picture. A data analyst now comes to the picture and will have a discussion with the principal of the university and say, okay, what do you really want? What's the problem? The principal of the university, often when they hire a data analyst, they don't actually have a clear definition of their problem. So they'll be like, I just want to know what's happening with my school fees, and I just want to know what's happening in performance in this university, or just give me some basic stats. I just want to know what's happening in my university. Then the data analyst will be like, okay, let me start my work. So the data analyst will create certain questions. I want to certain questions. What is the top university? What is the let me just extract all the data. So the data analyst will extract. That's what we call retrieve. We'll retrieve all that data from the database. So it will retrieve the students, the courses, the fees. It will retrieve it, and that's what we call data retrieval from the database. And the data analyst will start his magic. He'll start trying to clean the data, because sometimes we may have people who have not put in their first name, or they have not put in their last name. So in the column of last name, some people will have what we call missing values. So they will have no last name, because when they were registering the form did not specify that last name was compulsory. So some people will not put in last name, and they'll have no last name. Some people, maybe their second phone number was not compulsory. They will not have no second phone number. They'll have errors in their addresses. So some people put addresses which have errors. So when you try to search for that address, you can't see the address, because when they were inputting the address, it had an error. So you have all of this. That's what we call issues with the data. So the data analyst retrieves that data, first thing, he'll start trying to look for this inconsistency. Is there missing values in some of the columns? Is there inconsistencies in some of the columns? How do I clean it? How do I transform it? Then after he cleans it, he'll be like, okay, let me start answering the questions which will be of interest to the principal. The first question is, let me just identify the number of students who have not paid school fees and number of students who have paid all their school fees. And you now have a plot that shows number of students who have paid their school fees, number of students who have not paid their school fees. And he keeps asking questions to the data, keeps asking questions, and he has these visualizations and this information which he can present now to the to the to the university. And the university is like, wow, all of this information, I didn't know about it because it was data, but now it's information which has been produced by the data analyst. And the university now says, okay, can you not build me a predictive model which will predict that if this kind of child registers, the child has a high probability of not paying school fees. So you can imagine now, so every child that registers, the data analyst now will create a machine learning algorithm that will use all past information of students who had registered and the school fees they paid to create a predictive model. Then every time a student registers, the predictive model will tell the university that this student, I'm not sure this student will pay the school fees. Then the university will be like, when you are registering, the university will be like, you have to pay upfront, else you will not attend any class because the system has already identified that you are high risk. So that's the whole story, right? So as I said, the first part is to retrieve the data, and that's where SQL comes into play. So SQL is used by the data engineer to create a database, to create these tables, the students and everything, to insert the tables from systems, and used by the data analyst to retrieve the data, transform the data, and bringing the data now to a Python environment to analyze the data. So there's SQL environment where the data will be retrieved and taken out to a Python environment where he will do the analysis, the visualizations, and the machine learning. So that's where SQL comes into play. Again, I've just showed you methods of which data can be inserted into the database. So first is it can be manually inputted into the database by the data engineer from the back end. So we will see when we start analyzing SQL, we'll see how we can, using Visual Studio, we can input data into the database. We can say, okay, this student put his name using code. So we use code to manually input the data. Secondly, you may not use code. So what we call a back-end programmer. I think you have heard about back-end programmers. So a back-end programmer now will write code that will interface at the end of a form or a survey. So when you go and click the form and you put in your information, you put send, the back-end programmer has written an SQL code at the back end of that form that will take that information and insert it. That will take that information and insert it into the database. We also have sensors. So imagine Tesla cars that are capturing data when the car is moving, all that information. There's still a back-end developer that is taking all that information, that's written code that takes all that information from the sensors and sends it directly to the database, again using SQL. So the back-end language will be SQL. So he'll write it in SQL, but when the data comes in, it will come in from the car, enter the SQL code. So you will update the SQL code and send that SQL code to the database. We have systems, as I said, if you have your university system, you are registering, that information will be sent to the database. And also you have user interactions. So that is SQL. The second thing is, as I said, when the data is captured, it will be taken out to an environment where we need to analyze the data, which is Python. So we'll be using a Python language to analyze the data. SQL will be the language we use to retrieve, and sometimes we do transformation as well. So we can retrieve the data and transform the data in the SQL environment. And in the Python environment, that's where we do analysis. That's why in the beginning of this course, I was planning to teach you only Python, because Python is a language where you do the analysis. But I discovered it's good to also inform you of how to retrieve the data from the database, and so you have a knowledge of SQL as well. So this table is just briefly, as I said, Excel is another data analysis tool. So, and a lot of people ask me, why not use Excel? Why use Python? This table just tells you why you have to use Excel and why you have to use Python over Excel, and in what scenarios. So obviously Python is used for larger data sets. Excel ends, I think, about 1 million rows. But imagine a data set of tweets that we're talking about millions and billions of tweets a day. So you cannot analyze that data in Excel. You need to use like a Python environment. It's very powerful when you are dealing with complex data transformations and data manipulations. You obviously, a lot of people know Excel. So Excel, you can do sum, average, you can do mean, max, but a lot of times where you have to do very complex algorithms, very complex workflows, and that's where Python comes into play. Obviously, Excel has what we call macros, which you can also do these complex computations using macros. But why do you want to learn macros? Macros is also a programming language. Why don't you learn Python, which you can use for any data, than learning macros, which is very specific for Excel, right? So that's why, and macros also, it's a programming language like Python. So Python then it has a lot of visualization tools. Excel has some basic charts like histograms and so on, but Python has more complex visualization tools, visualizations that you can do with Excel. You can do a lot of statistical analysis. So looking at how two things differ. So are they more males or females in the university? Looking if the statistical test, doing statistical tests to see if the number of males that pay school fees is more than the way females pay school fees, or those kind of statistical tests. And there's a lot of things you can do. You can do web scraping. If you want to take tweets from the internet, you can use Python and just collect tweets from the internet. And it's easy to share your code. Excel, you need to share the entire Excel sheet with someone. But with Python, you just share your code independent of the data. So you can easily share your code. And it has a lot of libraries, which you get to play with around, which obviously Excel does not have. And obviously, this is just a basic information. As I said before, we'll be dealing with structured data, right? In this case, obviously, you can already see this is a time series data. So we have date, we are looking at sales over time. So we have date, we have the sales, we have the expensive, we have the customer count, we have overtime. We're looking at those kind of things. So I just created this data set just to show you an example of what a data pipeline would look like. So the data analysis pipeline will have the following stages. As I said, we have principles in data analytics, but everything is not as straightforward. So first, you retrieve your data using SQL. Sometimes the data will already be given to you as a CSV file or as an Excel sheet, or the data will be given to you already. So most often you wouldn't even have to retrieve the data from the database. But if you're working in an organization that has a database, you may be required to retrieve that data from the database using SQL. When you get that data as a CSV file or whatever format you have, or if you are retrieving it directly from SQL, you will load that data into the Python environment. In our case, it's the Visual Studio Code, right? Visual Studio Code supported by the Jupyter Notebooks or Python. So you load that data into that environment. So that is like the place where you start coding. You start doing exploring. As I said, I already mentioned different things that can have issues in the data. You start understand. The first thing is to understand the data. So what we call describe the data. You want to know how many rows, how many observations, how many columns, what is the distribution. You just do some basic exploration of the data. Then you clean the data. As I said, there may be missing values. There may be inconsistent values. You try to clean the data. Then you do visualizations and you do hypothesis testing. You try to test different hypotheses. You test if the number of, as I said, the number of the nationality, maybe Africans pay more school fees than Caucasians or than whatever. You test those hypotheses now using statistical tests. So you test two different hypotheses. Then you build machine learning, as I said, similar to predicting that a certain individual or a certain student is going to pay school fees or not pay school fees. you do that machine learning where you're doing prediction. Remember, machine learning, to build the machine learning, you need historical data. So if you want to predict sales of a company, you need historical data of sales. You need to see how different sales had occurred in the past to predict the probability of the future. So you are always using data. Machine learning is all about data, using historical data to predict the nearest future. Then, so that's all about Python. So this is the entire Python pipeline, and that is SQL. This is what will be what the use of SQL is to retrieve data, transform that data. You do some limited transformations, just a minimal transformation in the SQL. This is depending on the question you want to answer, depending on the analysis you want to do in the Python environment, you do a little bit of some transformation. And remember, the retrieval, as I mentioned, in that database, we have students, courses, teachers. So the retrieval is not as easy as just retrieving students. Sometimes you want to retrieve students and courses that meet a certain criteria. Because imagine you're working in a company. For example, I was working in Orange, and in Orange we have data, millions of data that come in from financial transactions. So imagine you want to retrieve data, you want to retrieve and analyze data that of only the last 3 months. You don't go and retrieve the entire data, right? So you retrieve data that meets a certain condition, and that condition is the condition you need to analyze the data. So the condition can be you need data only for the past 2 months. The condition can be you need customers transactions for only customers who have subscribed to a certain service. So imagine Orange customers who have subscribed, who are doing who are doing peer to peer, or who are sending money to family members peer to peer, or Orange members who are doing business. So you want to retrieve only customers of Orange who are business customers within a certain period. So you have those conditions within your retriever, especially in a company where the data is quite huge. You cannot go and just extract all the data. So you have conditions, but those conditions obviously will teach you how to add those conditions when retrieving, how to join different tables. So you want the information about the students and the information about the teachers in the same table. But remember, in the database, the information about the students and the teachers are separate because they are in different tables. But now you want to combine the information about the students and the teachers. So you have to do some what we call joins. You have to combine different information from different tables. So the SQL code can become very complex, which is what we'll teach next week. And also the exercises I'll provide this week will be on SQL to start giving the foundation of SQL. You will install SQL, you go through the code, you go through certain functions to understand how to combine code, how to use conditions, how to add conditions like what I've described, and so on and so forth. So by the end of next week, the whole plan we'll already be experts in SQL. We can already extract, retrieve data from any database using any information. We'll have some good databases which we'll play around with. So by the end of that, we'll be able to use very complex queries, extract and join things, and use different conditions to extract the information we want. Remember, it's all about answering questions. So you don't have to master these things. In the real world, they will ask you, can you retrieve data for students who are above this age only? And you will write the condition. So you don't have to cram these things. It will come natural when you want to answer the question you want to answer, or when you want to get the information which you want. You understand? So that said, I'll quickly round up the next 10 minutes with job requirements. So as I said, these are screenshots of real world requirements. I took them from LinkedIn. So I just took the requirements, the responsibilities, what the experience required, and things that are being what people in the job market want from from the jobs they post as a data analyst, what they want you to know. So to your right, you can see it's obviously developing effective data analysis specifications, solid statistical principles. I will teach you how to what how to do statistical tests, how to come up with hypotheses and test this hypothesis, how to do visualizations. So we'll do a lot of visualizations. Obviously, we'll not be using Power BI, but we'll be doing visualizations in Python. So you will learn how to do visualizations, how to do reports and charts. Reporting is what I said before, the data portfolio, how to report your findings, how to report these things. Again, yeah, we are still talking the same, how to interpret, collect, mine, and analyze data and interpret the data. We have to report. Reporting is a part of data. It's all about the storytelling. You have to be able to report analysis on the performance of the data. So report different things, the sales, the customers, the products, and so on and so forth. And again, you have to be able to understand visualization tools. You see, Excel is always part of it. That's why the foundational requirements was Excel, because sometimes in some smaller companies, you may not need to use Python. You may just use Excel, but now I'm teaching you how to use Python for bigger data sets. Some people want computer science. Obviously, it's not important. You just need the tech. As I say, you just need the technical field. You just need technical know-how. You have to problem solving, which is what I was talking about. The mindset. You have to be analytical. It's still the mindset. You have to be able to research the mindset, and so on. Lastly, we'll go to, yeah, you have proficiency in SQL, which is obviously what you will get by the end of next week. You have Excel. You need to know advanced Excel, and advanced Excel are two key aspects. As I said before, pivot tables and VLOOKUPs. If you understand pivot tables and VLOOKUPs, that's advanced Excel. And I sent a link for us to be able to understand VLOOKUPs and pivot tables. So go through it. If you have any questions, please let me know. Solid experience with database systems is obviously SQL. You have Python, you have SQL, you have pandas, and so on. So it's all about SQL and Python, all about retrieving data and analyzing data and reporting data. So if you can get those skills, remember we are getting skills. If you can do those things, you can excel in the field of AI and the field of data analytics. Again, data scientist, which is more complex than data analyst, again, has the similar requirements. It's all about Python, all about visualizations, all about Python, all about translating general questions and problems to clearly define algorithmic solutions. I told you at the beginning, most of the companies don't even know what they want to solve. They just come and tell you, I have this data, the questions are very vague, so you have to collaborate with them to be able to define the questions they want to answer. What do you want to add? What do you want to know in your data? Do you want to know the top things? What do you want to predict? Sometimes they don't even understand this thing, but they have data. And when everybody has data, they become excited. Oh, I have data. I just need a data analyst. I just need a data scientist to come and do some magic. And sometimes it's not magic, right? Yeah. So we have to know, this is a very good one. I love this responsibility. You have to know data integration, data cleaning and imputation, predictive analytics, collaboration and communication. In fact, this responsibility defines the entire course outline for this course. So it's all about all of these different steps. Then the delivery method to end with will be as follows. Every week we'll have a three hours lecture. And as I said, we have pushed the hours to 10:30 a.m. to 1:30 p.m. British summertime. So that so you always use the British summertime. So within those 3 hours, we'll have 10 minutes breaks. The first minute will be a presentation by me to introduce concepts and to explain things very detailed as I am explaining now, and make it very subtle so that you understand the basics. And I'll try to use very clear examples as universities or as an e-commerce shop or just basic or a bank. I'll use all the real world examples that we are all familiar with to explain concepts. After that, we have a 10 minutes break. Then the next hour, we go into hands-on immediately. During the hands-on, I'll be live sharing my screen and coding and asking questions and interacting with you, the audience, and explaining concepts which I've taught in the PowerPoint during the live share and doing the live coding. So I'll share my screen and I'll code with you. I'll let people ask me questions and tell me why, ask me why questions, why did you not do this? And we will have that interaction. During that session, I will encourage you to also have your Visual Studio open as well to work with me. So when I'm trying things, you can be trying your own things. Some people may not be fast typers. I'm not a fast typer, but let's work together. We'll have these hands-on sessions. The code will be provided to you about 3 days, even before the week. At the beginning of the week, I'll provide, like next week we start with SQL. So I'll provide the SQL code which we'll be using to go through the exercises, and you can start looking at the code. You can start trying out the code in your Visual Studio to understand what the code is doing, so that you even come with more questions. And instead of coming to learn, you come with questions. Remember, we are doing a course which has to do with a lot of learning and a lot of continuous learning. And so you have to do most of the learning, try to do that individual learning yourself, and bring a lot of questions to me. I'll still do the lectures, I'll still do the coding, I'll do everything, but bring questions. What I want is questions. I want to see people's code break. I want to see your code. You try something, write a select statement, and the select statement doesn't work. And I'm happy because we both of us will sit and we'll try to resolve it together. And through trying to resolve it, you understand the concept double, and you understand it more and better. So we'll be using that live coding session. We'll have a 10 minutes break again. Then we'll move on to another live coding session. So we'll continue the coding session. Obviously, throughout this coding session, we'll be using a lot of co-piloting to speed up our program. And I'll be showing you how to use co-pilot to code and to do these things and to speed up our learning. We just have 11 weeks to learn a very applicational course. As I said, data analytics is very applicational. It's all about answering the how, the what, and the why questions about data. But so it's very important that we use Copilot to speed up our learning and bring a lot of questions. As I said, bring your data. If you have data sets in your company, bring it to your Visual Studio and start playing around with that data using the concepts I'll be teaching you throughout the course. And obviously at the end, we'll have a 5 minutes, 15 minutes question and feedback. So I'll encourage everyone to always complete the feedback exercise. The feedback as well will give me more information about my delivery methods, what I'm doing correctly, what I'm not doing correctly, the speed at which I'm going, if I'm going too fast, if I'm going too slow, if everyone's understanding, because there are some people who are already programming in Python who are here but want to be experts in Python. So maybe sometimes I'll be very slow for them. There's some people who are very new to all the concept I'm teaching here, so I'll be very fast for them. So the feedback will help me to improve my tutoring skills to ensure that we build this African data analytics community. Thank you, and that's the end of this session. So I think we'll have that's 10. So we have about 20 minutes. So the next 10 minutes, I'll just try to take questions. So first, let me go to the question portal and see the questions which were asked. Did your historical data tell you the names of those who will complete their fees for this training? That was a good one. Yeah, so I need to build a machine learning model. I think so. You have given me a good idea, and I can start with that for our machine learning course. So when our machine learning course will start, I'll start by giving some fake IDs to some of my learners and putting the numbers and see if there is some information about Cameroonians paying more than Americans or the UK paying more than. It will be interesting, yeah. So we're going to try that out. That's a good question. Um, um, there is also, does Python also come as a standalone statistical package like State? Okay, yes, yes, exactly. So Stata, I've been using Stata a lot for a lot of analysis. Python also has all of the statistical techniques which you can use in Stata. For example, if you want to do a t-test, if you want to do, obviously some people may not be familiar with the terms I'm saying. I'll add this in the glossary as well. So I'll add what a statistical test is. I'll add what the different types of statistical tests are. I'll add all of this in the glossary. So please feel free to um to to add to your feel free to look at the. So I'll just add this in the comment in the chat. So this just for my to remind me. So I'll add statistical test meaning. So as I said, the statistical test, we are just trying to test two distribution or two concepts. So for example, imagine as we're talking, we want to see if the people in America, my learners in America, are paying more or are paying more than my learners in Cameroon, for example. So in the statistical test, we'll test these two distributions of learners and we'll give a statistical value, what they call the p-value, which obviously I'll add. If I've not yet added, I'll add the p-value as well. We'll give a p-value which will tell us if there is a statistical difference between these two concepts we're trying to compare. And if there is a statistical difference, then we will say, okay, the learners in America or the learners in Cameroon pay more than the learners in America, for example. So most likely a lot of social science or yes, a lot of social scientists use data. So they use data. Data is a very powerful statistical tool, and I wouldn't say you should replace data with Python. But sometimes when you are already doing the analysis on Python, you don't want to move the data and go again to Stata to do the statistical analysis. Sometimes we do it when the statistical tests are very complex, which obviously Python doesn't have the capability. Then we moved our data to Stata to do maybe some more complex statistical tests. But currently Python has progressed over the years. So most of the statistical tests from ANOVA test, so which I'll put as well to t-test, all of the most of the statistical tests to test how significant two distributions or how different two concepts are now implemented on Python. So you can write code as well to test your distributions on Python as well. However, if you're already good at Stata, keep using Stata for your statistical test, and you don't need to actually use Python. You can skip using Stata and SPSS. So there's Stata, there's SPSS, and so on. Yep. Any more questions? Is there a difference between SQL and Python? Yes, the difference is SQL is used to retrieve data is used to create the data. So if I go back, sorry. So yes, SQL is used to create the database, create the tables in the database, insert data into the tables, and to retrieve data from tables. Python does not do that. Python is used to analyze the data. So that's the two difference. So most often, if you want to do data, like a lot of data engineers, if we have data engineers here, a lot of data engineers use SQL every day of their life, while a lot of data scientists like myself, we use Python every day of our life. I've been fortunate to know both because I've worked as a data engineer and as well as a data scientist. So I know both. And currently, if you look at the job market, as I said, a lot of companies now are trying to just ensure that even I hire you as a data analyst who is just supposed to come and analyze the data, I still want you to be able to know SQL, to be able to retrieve data from the database, because I want you to, there's already a database. I don't want to hire a data engineer to be doing that. I want you to be able to retrieve data, write queries to the data to get the data, then you do your analysis. So there is this, and the job market is quite hard now in every domain. So they are merging a lot of things. So that's why for me, it's very important for us to learn how to create the data, to create the tables, to retrieve the data, and as well learn how to analyze the data, which is with Python. So because sometimes you go to a job, and I don't want people to get frustrated when you go for an interview or you're talking to someone and the person asks you, do you know SQL? And you're like, no. And you say, no, you paid £1,000 and they taught me only Python and that guy told me I'll get a job. No, I want you to learn the entire pipeline, which is SQL and Python, retrieving the data and analyzing the data and making predictions. Then do we have any more questions? Seems have anyone be using the Q&A? Oh, okay. There's someone has used the Q&A, which is good. So I'm new to data and I followed your YouTube videos on how to set up Visual Studio Code and then Copilot on Mac, but it wasn't easy. I had to use YouTube to assist me in downloading and installing them. Is there a way you can check that we have all the correct software installed before the start? Perfectly. So Palm, that's a good question. I've had a lot of I was in Cameroon and I had to sit with a learner for about 2 days or 3 days just to install Visual Python, especially on their Mac. So unfortunately, and I apologize sincerely that I didn't take that into consideration. I thought it was as easy as Windows. But obviously, because I've installed it now on several learners' laptops, which are on Mac, I think if you are facing any issues with your installing Visual Studio or Python or Jupyter or whatever you're installing, after this, we'll have SQL as well to install on your Mac or on your Windows. Again, it's very easy with Windows. I hope it will be easy with Mac. If you have any issues, please let me know. And as I said, I'll go through each and every one of us before next week to ensure individually to ensure that everyone has successfully installed Python. So there are certain things I'll just tell you to write, a certain code I'll just tell you to write maybe hello world and print it. If I see it, then I know you have installed. If you have not installed it, I'll have a session with you where I will maybe book a 15 minutes video call, get access to your computer and try to install it for you. Also, there are a few things I would like people to do. I'll share the things. So as I said, there are set a few more things. So people will have to install SQL, will have to install. I'll send this. I'm just putting this for my information. So people will have to install SQL. People will have to install what we call Live Share, which is an extension in Visual Studio Code. This extension is very important because when you have issues during your coding session, you're able to give me to live share your Visual Studio and I'll be able to access it from the comfort of my home and help you to debug and you'll be seeing what I'll be doing. So instead of me trying to tell you that, no, put a comma there, I'll just go there, do a comma, and I'll be keeping you updated with what I'm doing. So the live share is very important. But I'll send a list of things which we'll need to do before our start next weekend as well. And I'll send a link to a lot of fundamentals for SQL. So I'll really encourage people to start writing code on SQL, create a table, insert some data into a table, query the table, do all of this before our lectures on Saturday. Another question has come in. Important and the course we did by hand was good. Any course on SQL me by same yeah. Yeah, her teaching method is top notch. Yeah, I have to maybe book a session with her for her to teach me as well how to teach. Yeah, but she's a amazing tutor as well. So I will try to get a course on SQL, more in-depth course which you can go through as well, even it's with Hunt or not with Hunt, but I'll do my research to get an easy one. Obviously, as I said, I'm aware of people's background, so I'll get one that will be very interesting as well, simple for novice as well, and for people to interact and have fun. Before at the end of this lecture, I'll send all of this information. Sorry, guys, I know a lot of us are professionals. We have our day-to-day jobs. We have families we have to take care of and we also have exercises we have to do, but we are in a life where we just have to grind, right? And as I said earlier, it's an applicational course, so you can't wait for Saturday to just learn. You need to book in at least, I would say, if you book in 2 hours during the week, 1 hour maybe on a certain day, and that's excluding the drop-in sessions, right? You book in your personal, that's for your personal your personal learning, individual learning. If you book in 2 hours, 1 hour doing a certain time, another hour to do your personal, your individual learning, it will be very important. So you come in with the drop-in sessions with questions and problems as well, and also with insights and interesting results you're getting as well, and asking, was this the right way to do what I did? If I analyze the data, if I clean the data this way, was it the right way to clean the data, and so on. So that said, thank you so much, and we'll have a 10 minutes break, and we'll be kicking off again for the last session in 10 minutes. So keep sending your questions, I'll answer any question. Even if I'm not answering now, I'll answer later on in the chat. And yeah, thank you everyone. Again, use the link, the TED link. In the future, I think I'll just send one link for the entire 3 hours. But for now, use again the TED link so that I was still trying to learn certain things as well. But I think from next week we'll just have one link, which is 3 hours. We'll take the breaks, but we'll have one link so that people don't have to keep track of multiple links. And I apologize for that as well. So see you soon. Get a cup of tea, cup of water, walk around, and see you in 10 minutes.